Have you ever looked at an app on your phone and just wondered, how did this get here? How does an idea become something you can actually tap and swipe? It might seem like some kind of tech magic, but really, there's a pretty clear path. So today, we're going to break down that exact journey from square one for a brand new Android app. Let's get into it.
Oh, yeah, we've all been there, right? You get that lightning bolt of an idea for an app that would be so useful or just really fun, but then where do you even start? That big, exciting idea kind of fizzles out because the road ahead just seems way too complicated. Well, I've got good news. It's probably a lot more straightforward than you think.
You know, the easiest way to get your head around this is to think about it like building a house. Seriously. You wouldn't just start throwing up walls, right? First, you need a solid plan, the blueprint. Then, you actually build the structure, the walls, the windows, the roof. That's the look. And finally, you have to wire it all up for electricity and plumbing to make it functional. That's the brains. We're going to go through each part one by one.
So first things first, just like any good builder, before we can even think about construction, we have to set up our workshop and get all our tools ready to go. For us in the Android world, that means creating our project in just the right environment.
And this is that workshop. It's called Android Studio. You can think of it as the ultimate all-in-one command center for building an app. It's where you'll write the code, design how it looks, and manage every single file. It's the official toolkit from Google, and it's built to handle this whole process from start to finish.
So one of the very first things you decide is, well, who actually gets to use your app? These SDK levels are how you set those rules. The minimum SDK is you saying, hey, my app will work on any phone that's running this version of Android or anything newer. The target SDK is the version you've really fine-tuned and tested for. And the compile SDK? That's just a version of the Android tools you're using to build the whole thing. It's a balancing act, really, between using cool new features and making sure as many people as possible can download your app.
All right, we've created the project, and now our workshop is full of all these new folders and files. It can look a little overwhelming at first, but before we touch a thing, we need to understand what we're looking at. It's time to learn how to read the blueprint for our digital house.
When you get right down to it, a brand new Android project really boils down to just these three main things. You've got an activity, which is basically a single screen in your app. You have your resources, and that's all the stuff your app uses, like images, text, and layout designs. And then you've got Gradle files, which are kind of like the construction foreman who puts everything together at the end.
And what's really important to get is that this isn't just a random jumble of files. It is a super organized system. All the logic, the brains, lives inside the Java folder, and all the visual stuff, the look, lives inside the res folder, which is just short for resources. Keeping these two separate is absolutely key.
Okay, we've studied the blueprint, we know where everything is. Now for the fun part. Let's start building. It's time to lay the foundation and put up the walls. This is where we create everything the user is actually going to see on their screen. Look at any app screen. Everything you see, literally everything, is something called a view. It's the most basic building block you have. A button? That's a view. An image? That's a view too. A line of text? You guessed it, it's a view. Think of them as individual Lego bricks. They're the little pieces you use to build your entire creation. So how do you actually place these Lego bricks? Well, you use a language called XML. Now, I know it might look like scary code, but it's really not. It's more like a set of instructions you're writing out. All this is saying is, hey, Android, I want a text element, make it just big enough to fit its content, and make the text inside say, hello world. See, it's really just a description of what you want. And boom, there it is. That simple descriptive XML on the last slide creates this text right here on the screen. It's a direct one-to-one relationship. You describe what you want, and Android builds it. This is so powerful because it means you can design how your app looks completely separately from how it works. But you can't just have a random pile of Lego bricks sitting there, right? You need one of those big, flat base plates to build on. In Android, that's called a view group. It's basically an invisible box that holds and organizes all of your other views. If the views are the furniture, the view groups are the rooms that give everything structure. For instance, one of the simplest containers out there is called a linear lineout. Its only job is to neatly arrange all the views you put inside it in a straight line, either one on top of the other or side by side. This is how you start to build really complex, organized screens from all those simple individual pieces. So all this stuff we've been talking about, the XML layout files, any images or icons you use, even the bits of text, they're all known as resources. They are the pre-made parts that live neatly in that res folder we saw earlier, just waiting for your code to come and use them.
Okay, our house is looking pretty good. The walls are up, the windows are in place. But right now, it's just an empty shell. If you walk in and flip a light switch, nothing happens. It's time to install the wiring, the plumbing. It's time to add the brains that will actually make our app come to life. The brains behind every single screen is a file called an activity. And remember that separation we talked about? Well, the XML file defines what the screen looks like. The activity file is where you define what it does. It's where you write the actual logic that makes things happen when the user starts tapping around.
So how does that actually work? Let's take a simple button press. When you tap a button on the screen, the Android system basically sends out a little signal, a click event. Now, your activity code has been set up to listen for these events. When it hears that click signal from that specific button, it immediately runs whatever chunk of code you told it to. It's a really simple but powerful system of cause and effect.
But wait, how does the code know which button was pressed or which piece of text to change? Well, this is where it all comes together. Back in our XML blueprint, we can give any important view a unique name, or an ID. Then, in our activity code, we can just say, hey, go find the view with this exact ID and change its text. That ID is the essential bridge that connects the look and the brains of our app.
We are so close. We've got our blueprint, we've built our visual structure, and we've wired up all the interactive logic. Now it's time for the final steps, assembling all these pieces into a finished product and then adding that layer of polish to make sure it's great for everyone.
Meet Gradle. Now, I know this can look a little intimidating at first, but its job is actually pretty simple and amazing. Gradle is the automated construction crew for your app. It takes all of your separate pieces, the code, the layouts, the images, and it expertly compiles, packages, and assembles them into that single final file that someone can actually install on their phone. It just handles it all for you. Okay, let's talk about polish. What's up with this number? While 48 dp is the minimum recommended size for anything you can tap on screen. Why? Because that's about the size of an average adult fingertip. Making sure your buttons and controls are at least this big is a huge part of accessibility. It prevents those frustrating mistaps, and honestly, it just makes the app easier for everyone to use. And here's another huge piece of that polish: color contrast. This is not just about making things look pretty. Low contrast text can be literally impossible for people with vision impairments to read. And let's be honest, it's hard for any of us to read in bright sunlight. Making sure your text has enough contrast to be clear is one of the simplest things you can do to make your app way, way better. And there you have it. From setting up the workshop in Android Studio to drafting the blueprint with XML, creating the look with views, and then giving it the brains with an activity. You now have the fundamental pattern for how an application really comes to life. You've seen the how. So I guess the only question left is, what will you build?